for our next example, it says design a class named quadratic equation for a quadratic equation ax squared plus bx plus c equal to 0. The class contains the following data fields. It consists of a, b, and c as the three coefficients, c, a, b, and c. And you know that this is a quadratic equation. If it is equal to 0, we need to find the value of x makes this equation equal to 0. In fact, since this is a quadratic, so the maximum values for x will be equal to 2. And these are called roots. So we will define a class called the quadratic equation. And inside it will have three data fields, a, b, and c represents the coefficients. And also it will have a constructor that as an argument that initializes the class with a, b, and c. So when the user wants to create an object from this class, supposed to supply the values for a, b, and c. Also, we need a method inside called getDiscriminant, and that returns this discriminant, which is b squared minus 4ac. And remember that this equation is supposed to be inside the square root, so it's called discriminant. Also, we need to define two methods, one that will give us the first root, and the second will give us the second root. And to calculate the first and second root, we use these two equations. So we have square roots, one with minus b plus c plus, and here we have minus. But this depends on the value of the discriminant. These methods are useful only if the discriminant is non-negative. Otherwise, we will have imaginary solution. Let these methods return 0 if the discriminant is negative. So we will test for discriminant. If it is equal to 0, then the roots will be equal to 0. Otherwise, we will return, each of them will return the roots. So write a test program after we finish from the class. Write a test program that prompts, it means ask the user to enter the values for a, b, and c, and displays the result based on the discriminant. If the discriminant is positive, display the two roots. If the discriminant is 0, display the one root. Otherwise, display the equation has no roots. Now we are in JGrasp. So let us create our class. So this is our class. We will call public class quadratic equation. And as we mentioned, that the data members will consist of double a, comma b, and comma c. Now for the constructor, to define the constructor, it is public. There is no return value, just leave it empty. And the name of the constructor should be the same as the name of the class. So I will just copy it and paste it. And if you remember that we need to supply the three values for a, b, and c. So double a, comma, double b, comma, double c. And now since the names of the parameters are the same as the names of the data members, then we are going to use this. So this dot a is equal to a, this dot b is equal to b, this dot c is equal to c. So the value a that's coming from outside will be copied into the data member inside, and the value of b that's coming from outside will be copied into b inside, and similar to value of c. Now we need to write the methods. So the class methods. The first one will be the discriminant. So public, here we need to write what is the data type for the return value. And remember, we will the question says or suggested the name get discriminant. And now we need to see what is it needs input or not. This method will return the discriminant. So the discriminant is an equation b squared minus 4ac. So it will return b times b minus 4 times a times c. Now since we don't have any conflict in naming, b is already inside the class. A is already inside the class and C is already inside the class, so there is no need for input parameter. Now you know that all these values B, A, and C are double, so we expect that this method will return a double value. So we have to write the return value as double. This is the first method. Now the second method will be get, okay, public. Now I need to know the return value. I will put the question mark and then get root1. And since it's going to get something, so we expect that it has a return value. And since it's going to return a calculation of an equation, and the parameters for this equation A, B, and C, and they are double, so we expect that the return value should be here is double. Now let's look at the equation that we are going to apply, and if all the parameters of this equation are already defined inside the class, so we don't need input parameter. So it will return divided by 2 multiplied by A. Here we have introduced before a library that has all math functions, so it will be minus B plus math dot sqrt, which stands for square root, and here inside you can call discriminant directly inside this method. So there is no need to do the calculation again, because see, this equation is already inside the square root. Let me show you the equation in the question. Now see, this is the question. For root number 1, it is minus b plus the square root c b square minus 4ac, which is the same value as discriminant. So there is no need to do the calculation again. Just simply call the method, and the method will calculate the discriminant for you and will supply it to the square root. But here we need to check for discriminant first. If you remember that it says if discriminant is negative, then we should not accept, or we should return as a root 0 as a. So let us save the discriminant in a variable, and I will just call get this discriminant here. Save it because we are going to use it more than one time, and here we will check if discriminant is negative, then return 0. Otherwise, return the equation that we have just implemented and put between brackets for square root DISCR as discriminant. See, I have saved the value for discriminant because it's going to be used twice, and every time you call the method it will spend time for the calculation. So we want to do the calculation once, save it in a value, and then use this value again. I will copy this method and we will paste it, but we are going to call it root2. So both are the same, except that the calculation here, instead of a plus, then we are going to have minus. This completes the implementation of the class. And if you want to use the class, remember the names of the data inside, and remember the names of the methods. Before we proceed, we would like to check that there are no errors. We did not save it, so it's called the quadratic equation. Save it just to check that we don't have any errors. Now we don't have any errors. Now we would like to go to the main program that's going to use this class. Now the question says write a test program that prompts the user to enter values for A, B, and C and displays the result based on the discriminant. So we need to check the discriminant before we print the roots. If the discriminant is positive, we will display the 2 roots. If the discriminant is 0, we will display the single root. Otherwise, we'll display the equation has no roots. Now this is our main program, and I called it Quadratic Equation Test App, and I have created the main method and also prepared the scanner for input. First, we will display a message prompt to the user for the quadratic equation ax squared plus bx plus c equal to 0. maybe we could write it on the same message. Please enter the values for A, B, and C. And we will read them on the same line, so I'm going to use a print instead of println. So here we need to read 3 values. So A is equal to n dot next double, and we need to define them here. So we need to define the values for A, B, and C coefficients, and repeat this for B and C. So this will be for B and this will be for C. After we read from the user, now we need to create an object, create a quadratic equation object. And how to create it? You bring the name of the class quadratic equation, give this equation a name, quadratic, and or maybe you can call it equation equal to new quadratic equation, and supply A, B, C for initialization. Now the object is ready. Now we need to check the discriminant. Since we are going to check for the discriminant more than 1 times, let us save it. Double discriminant is equal to equation dot get discriminant without any input parameter. Now we will check for the discriminant. If it is positive, then there are 2 roots. Then we will write system out dot println, and we will say root 1 equal, and how to get the root? We say equation dot get root 1 plus, we will go to next line and we will write root 2 is equal to, and we print equation dot get root 2 to print the second root. Else, if discriminant is less than 0, then we will print a message, or let us check for 0, but testing for 0 for double sometimes is critical because the computer approximates it. And we will say println the equation has a single root equals to, and here you just choose any method because both will give you the same answer, because under the square root is 0. So here you can say equation dot get root 1, or you call root 2, it will give you the same answer. Else, here we write system dot out dot println, and here we will say the equation has no roots. So we would like to test the program on the 3 cases. We will check for the first case if it has 2 roots, and we will check for the second case if it has only 1 root, and also we will check if the equation does not have any roots. Let us check first that the program has no errors. So we will check for errors first. Oh, we did not save it, so let us save it. And now we run it. So there are no errors, so everything is fine. So let us do the first run. So first run, It says for the quadratic equation ax squared plus bx plus c, please enter the values for a, b, and c. So I will check if a is 1 and b is 5 and c is 6. Remember, now there are two roots, and since 6 is positive and 5 is positive, so what are the two numbers when you multiply them? You get 6, and when you add them you get 5. They are 2 and 3. So root number 1, and they are negative because when you say x plus 3 equal to 0, then x equal to minus 3. So the roots are, one is minus 2.0, the other one is minus 3.0. Let us run the program again, and we would like to test the class if we have a single root only. So a is 1, and b is minus 6, and c is 9. And here it says that the equation has a single root which is equal to 3. For the last case, we will give 1, 1, 1, because the discriminant will be negative, and here it says that the equation has no roots, and this completes the implementation of our program.